A New Frontier Printing Life Itself, written by Neil deGrasse Tyson. Imagine a world where organ donors are no longer needed. Imagine a future where personalized medicine reaches a new level. This is the promise of bioprinting, a revolutionary technology poised to transform healthcare as we know it. Bioprinting is essentially three-dimensional printing, but instead of plastic or metal, it uses bio-inks to create living tissues. These bio-inks are carefully crafted cocktails of cells, growth factors, and other biomaterials. Layer by layer, these inks are deposited to build complex three-dimensional structures like skin, cartilage, and even organs. The potential impact of bioprinting on medicine is profound. It offers hope for patients awaiting organ transplants, a process often fraught with long waiting lists and the risk of rejection. It opens doors for personalized medicine, allowing for the creation of tissues and organs tailored to an individual's unique genetic makeup. The implications extend far beyond treating existing conditions. Bioprinting enables us to create highly accurate models of human tissues and organs for drug testing. This could dramatically reduce our reliance on animal models, leading to more effective and ethical drug development. Furthermore, these models provide invaluable tools for studying diseases and developing new therapies. Bioprinting represents a giant leap forward in our ability to understand, manipulate, and ultimately heal the human body.
The Architect and the Ink Bioprinting Deconstructed. The process of bioprinting is as fascinating as it is complex. It begins with a digital blueprint, a three-dimensional model of the desired tissue or organ. This model is then fed into a bioprinter, a sophisticated machine that acts as a biological architect. The bioprinter follows the blueprint, meticulously depositing layers of bio-ink onto a scaffold. This scaffold acts as a temporary support structure, guiding the growth and organization of the cells within the bio-ink. The bio-ink itself is the heart of the bioprinting process. It is a carefully balanced mixture of living cells, usually the patient's own, and a biocompatible gel that provides structural support. This gel, often made from materials like collagen or hyaluronic acid, mimics the extracellular matrix found naturally in our tissues. In addition to cells and the supporting gel, bio-inks often contain a cocktail of growth factors and signaling molecules. These molecules act as chemical messengers, guiding the cells to differentiate, proliferate, and organize themselves into the desired tissue structure. The layering process is crucial to the success of bioprinting. The bioprinter deposits the bio-ink in thin, precise layers, mimicking the natural organization of cells within tissues. This layer-by-layer approach allows for the creation of complex structures with intricate internal architectures, such as blood vessels and nerve pathways.
From lab to life bioprinting today. While still in its early stages, bioprinting has already made significant strides. Researchers and companies around the world are developing innovative applications for this groundbreaking technology. One of the most promising areas of current research is in skin bioprinting. Scientists have successfully bioprinted skin grafts that are being used to treat burn victims and patients with chronic wounds. These bioprinted grafts offer several advantages over traditional skin grafts, including reduced risk of rejection and faster healing times. Beyond skin, bioprinting is showing promise in repairing damaged cartilage. Researchers are creating customized cartilage implants for patients with joint injuries or osteoarthritis. These implants are designed to perfectly match the patient's anatomy, promoting better integration and long-term function. Another area where bioprinting is making significant inroads is in the realm of drug testing. Bioprinted tissues and organs provide a more accurate and ethical alternative to animal models. These models allow researchers to study the effects of drugs on human tissues in a controlled environment, potentially accelerating drug discovery and reducing the need for animal testing.
Pioneering the future of medicine. The field of bioprinting is driven by the passion and innovation of countless researchers and companies across the globe. One such pioneer is Dr. Anthony Atala, director of the Wake Forest Institute for Regenerative Medicine. Dr. Atala and his team have made groundbreaking advances in bioprinting, including the creation of functional bladders that have been successfully implanted in patients. Another leading figure in the field is Professor Jennifer Lewis at Harvard University. Professor Lewis and her team are developing new bio-inks and printing techniques with a focus on creating tissues with complex vascular networks. On the industry side, companies like Organovo and CELLINK are at the forefront of developing bioprinting technologies and applications. Organovo is known for its bioprinted liver tissues used for drug toxicity testing, while CELLINK provides a range of bioprinting platforms and bio-inks to researchers worldwide. These pioneers and many others are pushing the boundaries of what's possible with bioprinting, paving the way for a future where regenerative medicine becomes the standard of care. Their dedication and groundbreaking work are instrumental in bringing this transformative technology from the realm of science fiction into the reality of modern medicine. Looking ahead, the potential applications of bioprinting seem almost limitless. The most ambitious goal is the creation of fully functional, transplantable organs. Imagine a world where patients suffering from organ failure no longer have to rely on the generosity of donors or face the uncertainty of long waiting lists. Bioprinting offers the tantalizing possibility of creating organs on demand, tailored to the specific needs of each patient. These organs would be grown from the patient's own cells, eliminating the risk of rejection and the need for lifelong immunosuppressant drugs. While printing complex organs like hearts and livers still presents significant challenges, researchers are making remarkable progress. They are developing new techniques to bioprint intricate vascular networks and multiple cell types within a single organ. Beyond organ transplantation, bioprinting holds immense potential for personalized medicine. Imagine a future where doctors can take a patient's own cells, bioprint a model of their tumor, and test different drugs or therapies to determine the most effective treatment. This level of personalized medicine could revolutionize cancer treatment, tailoring therapies to each patient's unique tumor profile. Another exciting frontier is the development of at-the-point-of-care bioprinting. Imagine a scenario where a surgeon during a complex surgery could use a bioprinter to create a customized tissue graft or implant in real time. This would streamline surgical procedures, reduce recovery times, and improve patient outcomes.
The challenge of complexity, building functional organs. While the future of bioprinting is bright with promise, several challenges lie ahead. One of the biggest hurdles is replicating the intricate complexity of human organs. Organs are not simply collections of cells, they are highly complex structures with intricate networks of blood vessels, nerves, and specialized tissues. Recreating this level of complexity in a bioprinted organ is a monumental task. One of the most pressing challenges is vascularization, the creation of functional blood vessel networks within bioprinted tissues and organs. Without a proper blood supply, tissues and organs cannot receive the oxygen and nutrients they need to survive and function. Researchers are exploring various approaches to address this challenge, including incorporating growth factors that promote blood vessel formation and developing new bioprinting techniques to create intricate vascular networks. Another challenge is ensuring the long-term viability and functionality of bioprinted tissues and organs. Once implanted in the body, these structures need to integrate seamlessly with surrounding tissues and function effectively for the long haul. This requires a deep understanding of the complex interplay between cells, the extracellular matrix, and the host's immune system.
Ethical considerations. Navigating uncharted territory. As with any transformative technology, bioprinting raises a number of ethical considerations that must be carefully considered. One of the most pressing concerns is the potential for commodification of human tissues and organs. If we can print organs on demand, will this lead to a market for human body parts, potentially exploiting vulnerable populations? Establishing clear ethical guidelines and regulations is crucial to ensure that bioprinting technologies are used responsibly and equitably. Another ethical consideration is the potential impact on the definition of life itself. As we become increasingly adept at creating living tissues and organs, where do we draw the line between a complex biological construct and a living being? These questions challenge our existing ethical frameworks and require careful consideration as we venture further into the uncharted territory of bioprinting. Furthermore, access and affordability of bioprinting technologies must be addressed to ensure that these life-changing advancements benefit everyone, not just a privileged few. It is essential to have open and inclusive dialogues involving scientists, ethicists, policymakers, and the public to navigate these complex ethical waters and ensure responsible development and application of bioprinting technologies.
Bioprinting, a paradigm shift in healthcare. The rise of bioprinting represents a paradigm shift in healthcare. It holds the potential to revolutionize medicine, offering new hope for patients, accelerating drug discovery, and ushering in an era of personalized and regenerative medicine. From printing skin grafts for burn victims to creating customized cartilage implants for joint repair, bioprinting is already making a tangible impact on patients' lives. As research progresses and technologies advance, we can anticipate even more groundbreaking applications in the years to come. Imagine a future where organ donor lists are a thing of the past, where personalized medicine reaches unprecedented levels of precision, and where complex surgeries are streamlined with real-time bioprinting. This is the future that bioprinting promises. However, alongside the immense promise come challenges and ethical considerations that must be carefully addressed. Ensuring the long-term viability and functionality of bioprinted tissues, addressing the complexities of vascularization, and navigating the ethical implications of creating human tissues and organs are crucial steps in realizing the full potential of bioprinting. Open dialogue, thoughtful regulation, and continued investment in research and development will be essential to harness the transformative power of bioprinting for the betterment of humanity.
A universe of possibilities. As we venture deeper into the cosmos of bioprinting, we are met with a universe of possibilities. This revolutionary technology has the potential to reshape the landscape of medicine, offering solutions to some of healthcare's most pressing challenges. Imagine a world where chronic diseases are treated at their root cause, where damaged tissues are regenerated, and where the human body is no longer limited by the constraints of disease or injury. This is the future that bioprinting makes possible, a future where the boundaries of science and imagination blur, and where the impossible becomes possible. However, this future is not without its challenges: the complexity of the human body, the ethical considerations surrounding the creation of living tissues, and the need for equitable access to these transformative technologies are all hurdles that must be overcome. As we continue to explore the vast potential of bioprinting, we must proceed with caution, wisdom, and a deep sense of responsibility. The future of medicine is being written in the laboratories and the research centers where bioprinting is being explored and advanced. It is a future ripe with promise, a future where science fiction becomes reality and where the human body, once limited by its own fragility, has the potential to heal and regenerate in ways never before imagined.